Sawmill's not running today, so there's not going to be any sawing videos, but I do have one here that you might be interested in, so let's watch it together. I guess we'll start the in-depth review with the hydraulics. And we'll go through them. As I've mentioned in previous videos, we've got these levers here that control the hydraulic function of the system. This lever over here takes the log clamp and moves it in and out. Next one over here does the clamp up and down. The third one does two different functions. One, it operates the backstops up and down, and at the same time, it will operate the log turner. What will happen is when the log turner is all the way down, then the lever will raise and lower or rotate the backstops. But before the log turner will engage, the log stops have to be totally vertical, and then hydraulically it'll switch over to the turner itself. The next two are two that I am always forgetting, and those are the front and rear toe boards. As you've probably noticed a million times, I always seem to forget to lower them after I've raised them. Hopefully we'll get better on that, but who really knows. Last one over here is the log loader, loading arms, whatever you'd want to call them. They have a capacity of, I believe, 4,400 pounds, give or take a little bit. So what we're going to do is, again, get into a more in-depth on the hydraulics, and then we'll move over to the control panel. First thing on the hydraulics, we have the valve bank right here. We have a pump here, made in Germany by a company called Bucher. No, B-U-C-H-E-R, Bucher, not Blucher. Wood-Mizer could have gone with a Asian-made pump and saved themselves quite a bit of money, but they really gone all out using this particular unit. Works very, very well. Personally, I'd like to see a little bit more volume available as far as the cubic inches per minute, but or gallons per minute, however you want to measure it. It would make things work a little bit faster, but that's not what they have. So the other thing we want to show, and we're going to take a quick break for a moment while we get it in position. Along the bottom of the valve bank, you'll see that there's a series of levers, and regardless of which lever you're pushing, you'll see the bar that connects everything together rotates. I'm moving these, and it only moves a very little tiny bit. I'm hoping that you can see it. You have to look very, very closely, but you'll see that it's moving. And on the very, very end, on the left-hand side of the screen, there's a small micro switch. So we're going to zoom in on that a little bit. Okay, as each of the levers is operated, as you saw earlier, the main shaft on the switch operator rotates slightly. Whether you're taking a lever, raising it, or lowering it, that rotating shaft rotates in the same direction. But as you're pushing a lever down, you'll see that the micro switch is activated like that. And that little tiny micro switch right there, and we're going to go mobile again, comes up here and controls this solenoid. And this is a 12-volt DC operated solenoid rated at 200 amps DC, made by, and this one happens to be White Rogers, but there's other manufacturers. And the solenoid here is very similar. It's actually identical except physically larger, as you find in the older cars that have a solenoid operated starter for the motor. And this is rated as continuous duty, so if you were to go to your local auto supply store and get a motor starter solenoid, they're not rated for continuous duty, and within no time you'd probably burn it out. But anyway, we've got the solenoid over here, which operates the motor. which is right here. That's the pump portion, and over here is the motor portion. There's a hydraulic filter right there. And even though this isn't hydraulics, this particular battery and everything is part of the emergency braking system, breakaway braking system. The wires that are there go through the chassis, come out over here to this switch. I know I'm jumping around, but that's okay. And we have this pull cord which goes on the bumper of your vehicle. Okay, I guess the first thing that I want to show is a really cool thing how this thing works, and that is the switch over here for engaging the blade. Some sawmills have a manual lever that you operate to engage the blade. Matter of fact, most manual mills do. Timber King has a electrical clutch and brake assembly on their 1220, which is what I used to have. The LT35 and 28 have a manual lever you pull, and anything from a 28 down, I believe, has a manual lever also. The LT40 has an electrically operated clutch mechanism, and what we're going to do is show you how this thing works. I'm going to move up here. This unit right here, let me get on the other side. This unit right here is what moves this entire assembly up and down when you engage the clutch. There's a motor here, belt drive down to a gear reducer. Gear reducer goes over to the other side here, and you can see there is a shaft with an eccentric, and you'll see that operating momentarily. We have a couple of limit switches built in here so that the unit will stop by itself. And this motor only operates in one direction only. And when you see how this thing works, it's really quite cool. So here we go. Hold on. Okay, from this side, when we engage the belt, the motor, however you want to call it, engage the blade, turn the switch, you can see how the motor rotates a half of a revolution, or the output shaft rotates half a revolution, and that either raises the engine mount, as you can see, or lowers the engine mount. Now if we go over here inside, I think you can see it. Where are we? Let's see if we can see this thing work. There we go. You can see it right there. You'll see that mechanism in the back that goes up and down. That right there, there is a drive belt right here. This is a what's it called? A twin V belt with a band on it. I don't know the proper name. Down here, this is the brake mechanism, or the brake strap that goes onto a wheel. So when you engage the blade, when you engage the blade, the brake disengages, gets loose, and the belt gets tight. When you turn the blade off, the opposite happens. We lose tension on the belt, and the brake band tightens around the wheel. For you LT40 and 50 owners, you know that when you put a new blade on your machine, there's quite often a time when you want to rotate your band wheels in order to check for alignment, rotation, so on and so forth, make sure that everything is tracking properly. And under normal conditions, you can't do that because the band wheels are either locked because the brake is engaged, or locked because the drive is engaged. This is assuming that the motor's turned off, of course, so you can't turn the band wheels. But what I've learned is a little secret that you can free up the band wheel so you can check for your alignment and spin them manually. So obviously you need to turn the engine off, turn the key switch into the number 3 position, and standing next to the key, engage the blade, like this. And now holding onto the key, you disengage the blade, and as the motor starts to pivot downward to disengage everything, turn the key off, like that. And that usually will free up the brake and the drive. I didn't do that enough, so I'm going to try just a quick little on-off, like that. And now the band wheel is disengaged from the drive and the brake, and then you can rotate everything manually to check again for alignment and so on and so forth. Isn't that cool? Now the thing you have to be careful of is as soon as you turn the key switch back to either position, it'll continue to go in the direction it was going in before, so you got to be very careful with your fingers and so on. Okay, next on the list is saw head up down. That's controlled by this drum switch over here. Pushing the handle up or forward, it raises the head. Letting go, it goes back to the neutral or off position. Pushing down, it goes down. So let's go around to look at the motor itself. Okay, the saw head raise and lower motor is right back here, connected by a belt to this pulley down here, which is connected into a gear reducer down below here, the bluish colored unit. Shaft coming out of there to a double sprocket. Double sprocket is connected to the double chain, which if I go below here, you can see right there, that is where it's connected to the actual frame of the carriage. And the chain itself doesn't move. It's the head moves on the chain itself. So if we, when we raise the saw head, pushing the lever, we can see that the motor is running the reducer over here. Reducer is coming over here and basically climbing up the chain. And when we push down, obviously it goes back down the chain. Now let's move back over here to the input shaft and listen to the difference in the speed going up and going down. You'll notice that it runs at a higher RPM going down. That's because gravity is assisting. Now, one of the things that you'll also notice is what we're looking at right here is what they call the position sensor. I believe it's nothing more than a shaft encoder that counts the revolutions on the, or actually parts of a revolution on the input shaft going to the reducer, and that gets translated to a distance so that when you work with your simple set, this will keep track of where you are starting and where you're ending. And we'll get into the simple set at a later date. But that's basically how the up-down portion of this thing works. And let's move on to the carriage travel. Okay, moving on to carriage control, we have a drum switch on the left-hand side with that does the control for the carriage. Pushing the lever forward causes the carriage to go forward, variable speed. Pulling it back, the carriage goes in 2 speeds, on and off. I'm going to turn the switch off here for a moment. And you'll notice that push going forward, it locks in the forward direction so that you can use the speed control and not have to worry about holding onto this with one hand. And if you're going in reverse, it will automatically return to the center or off position. So let's turn the key switch back on again. And once the thing is all warmed up and ready to go, that drum switch will control this motor down here, which then through the 2 pulleys here is a direct drive to the chain right there. Now that chain, you can't see it clearly, goes through the shaft here on the large pulley, and it's just nothing more than a simple S connection. Chain comes in, goes around a pulley, and then back out again. So it's just a very simple S configuration for doing the actual drive. From time to time, this chain may need to be adjusted, but since this is relatively new and relatively unused, unfortunately, we haven't had to do any adjustments there. So let's put our speed control near 0, and we're going to go forward and Bring the speed up a little bit. There we go. We'll go kind of slowly. So that's all we have there. Just a simple motor turning a large pulley. Pulley's turning a small sprocket. Sprocket is creeping along the chain over there. Simple as that.